Hello, this is our third video for Chapter 8 in STA2023 Statistical Methods. Here we're going to talk about comparing proportions from two populations. So in this case we have two different proportions, and for HO, because we have two different proportions, HO is always equal, we're going to set the two proportions equal to each other. So the HO is assuming that they're equal to each other. HA, the alternative, is that the first is less than the second, or the first is greater than the second, or the first is not equal to the second. And because we have two groups, some things need to change. So what's going to change is, number one, the STA formula. Notice it's longer because we have two groups. And your z-score. We're going to take the first proportion minus the second proportion, and then it says minus 0. Now you'll notice I will not put minus 0 because subtracting 0 doesn't change anything. But what this means is the difference between the two groups compared to 0. 0 being no difference. Is there a difference compared to no difference? And notice that the conditions are a little bit longer because we have two groups. So we have to check out the first n with the first p and the second n with the second p. It does have to be random still, independent within samples, and the null hypothesis is assumed to be true. Okay, so it's better to start in with an example. So here it says the researchers from the Pew study interviewed two random samples. So stop there, we have two separate groups. Both samples, the one taken in 2002 and the one taken in 2009, had 15 people. They don't have to be the same, but in this case they are. If they're very different, then I'd worry, but in this case they're the same. In 2002, 645 people expressed support for stem cell research, and in 2009, 870 expressed support. Is the proportion of people in the 2002 group who support stem cell research not equal to the proportion of people in the 2009 who support stem cell research at the 5% level? So there's a lot of information there, but the big point is we have two separate groups. We have the 2002 group, and we have the 2009 group. So we're going to be very well organized. The first group, the 2002 group, had 645 people who supported stem cell research out of the 1,500, which is 0.43. The 2009 group, completely separate, totally separate group, an independent group, had 870 people that expressed support for stem cell research out of 1,500, which is 0.58. So the big question is, was there a difference between 2002 and 2009? They both had 1,500. Again, they don't have to be the same, but in this case they are. And our alpha is 0.05, and remember we're doing not equal to. So our HO again is equal. We're setting the first group equal to the second group, and we're being consistent. If 2002 is first, it's always first. 2009 is second. So the proportion of people in 2002 who support stem cell research is equal to the proportion of people in 2009 who support stem cell research. And our HA is P 2002 is not equal to P 2009. The proportion of people in 2002 who support stem cell research is not equal to the proportion of people in 2009 who support stem cell research. Now we're going to check our conditions. And again, because we have two groups, it's a little bit longer. So we have to check the first n with the first p. 1,500 times 0.43 is 645. That's greater than or equal to 10. 1,500 times 1 minus 0.43 is 855. That is greater than or equal to 10. Then we have to check the second group. 1,500 times 0.58 is 870. That's greater than or equal to 10. And 1,500 times 1 minus 0.58 is 630. That is greater than or equal to 10. The two groups are random. They're independent from each other. Independent within samples. We didn't have the same person twice within a group. And the null hypothesis is assumed to be true. Now the question is, when I go for my SE, it asks for p hat. Which p hat do I use? The first or second? The answer is we use a combined p hat. So we add the numerators, add the denominators, and then we divide. So we have this combined p hat. That's what we're going to use for our SE. So that'd be 1515 divided by 3000 is 0.505. So make sure we do that first. And then when we do our SE calculations, be careful. It's our combined p hat, 0.505, times 1 minus 0.505, parenthesis, 1 over 1,500. Plus 1 over 1,500, following this formula, n1, n1. And you should get 0.0183. So be careful when we do that. Practice that. Make sure you get 0.0183. Now, for our z, it's the first p hat, which is 0.43, minus the second p hat, which is 0.58. You could subtract 0, won't change anything. divided by your SE, 0.0183. Be careful, again, practice, practice. You get a z-score of negative 8.20. Now, we should be getting very comfortable with z-scores and understanding how z-scores work. Negative 8.20 is really far to the left, so that would be way out here. Now, remember, when it's off the chart, if we're on the positive end, we use 0.9999. If you're on the negative side, we use 0.0001. This is just an estimate. It could be 10 zeros and a 1, but this is just an estimate. The calculator can give you the exact answer. Okay? So we'll be using 0.0001, but remember, when not equal to and not equal to only, we double the p-value because not equal to checks both sides. Not equal to checks both sides. We got our estimated p-value of 0.0002. It's very small. It's 0.02%. Now, we can check this in the calculator. So when we go to the calculator, we're going to go to on clear stat tests, and the test we're going to do is a 2 proportion z-test. 2 proportion z-test. Now, notice we have all these blanks. We have 4 blanks because we want the first fraction and the second fraction. Again, it doesn't want the 0.43 and it doesn't want the 0.57 of 0.58. It wants the fraction. So if we go up here, here were our 2 fractions. That's what the calculator is looking for. So we have 645. Enter, out of 1500, 870, enter, 1500. This one's not equal to, you can go to calculate or draw. I'm going to do draw first. There's your picture. Remember, if you get an error at this case, it's probably because you have a plot on, so be careful with that. The same z-score we got. Let me scroll down here. Okay, very similar z-score. That double checks our work. And they're saying it's essentially 0. If you want to find the exact answer, we go to tests, 2 proportion z-test, number 6. Go to calculate. Your exact p-value is 2.12 e to the negative 16. Don't forget that part there. You move the decimals 16 spaces to the left. That's 0.1502. Very small. And when the p-value is smaller than alpha, which it definitely is, we reject HO. There is statistically significant evidence to reject HO because of a very small p-value. We conclude the proportion of people in 2002 who support stem cell research is not equal to, remember that conclusion chart, be practicing that, is not equal to the proportion of people in 2009 who support stem cell research. So what we're concluding is they're different. They're not the same. 2002 and 2009, there's a change. So the question is, what is that change? And that's what the confidence interval will help us with. So the formula for the confidence interval now is the first p hat minus the second p hat plus or minus z star times your SE. So we have 0.43 minus 0.58, giving us negative 0.15, plus or minus our z star is 2, or you can use the exact one, SE 0.0183. You get negative 0.187, negative 0.113. Now if we go to the calculator, stat tests, we did 2 proportion z test, which goes with a 2 proportion z interval, b. So the fractions put in there for us, double check. Confidence interval is 95, double check. And negative 0.18, negative 0.18, negative 11.46, negative 11.3. It's very close. Remember, the calculator is going to be more exact. Ours is a little bit of rounding, so be careful. But the more important question is, what does that mean? Why is it negative? So to understand that, we have to think of it this way. It's the first group compared to the second group. The first group compared to the second group. So 2002 compared to 2009, 2002 is negative, negative. Well, negative, negative, they're both negative means it's lower. If they're both positive, higher. If one was negative, one was lower, one was negative, one was positive, it would be lower or higher. So in this case, they're both negative, so we say we are 95% confident the proportion of people in 2002 who support stem cell research is between, notice I didn't put negative, I'm interpreting the negative, 11.3% to 18.7% lower. We're interpreting what the negative means. So 2002 is lower by 11.3 to 18.7% than the proportion of people in 2009 who support stem cell research. So 2002 is lower. Again, if these were both positive, 2002 would be higher. If one was negative, one was positive, we'd say it could be lower, it could be higher. And then I could say it would be the opposite of not equal to. Okay? Remember, all of your calculator steps are here to practice, practice, practice. Please use these resources and watch these videos.